Okay, so welcome to the Code Maven or Rust Maven, shall I say, meeting. My name is Gabor Sabo. I usually teach Rust and Python, and I help companies to introduce testing and related tasks. In this meeting and in this video, I'm going to try, I guess, for the first time, to do a public source code reading. And I try to sort of prepare myself as well. Um, and thank you for the sharing of the idea that I was looking for earlier. So in the meantime, sorry, I just forgot to make sure that my phone doesn't beep too much. So in this meeting, I'm going to go over the thousands crates, which is not a very complex crate. I try to prepare myself to some level, but I also try to somehow have this video as if I was encountering a crate for the first time. So it's a sort of I wasn't trying to be too surprised by some code or too obvious that I don't understand maybe some code. Let's see what we can do with this. So I'm going to share the screen and show you the code and show you, yeah, okay. Good. So hopefully you're seeing the website of meetup.com. And I can turn on this thing as well so people can still see me somewhere this is the website. This is the code the Code Mavens group on Meetup where you register. You can see here that that's very registered. Fine. If you're looking at the video, then please come to this group and register. There is actually another website called live.codemaven where I list all the live events that I'm trying to organize these days. I used to organize live events where I was talking, like this one, and starting from January, starting to invite other people as well. So if you'd like to present something, it would be very interesting. Talk to me. Okay, and I have thought of three main channels: Rust and Python, and somewhat also Perl, but also other things. And on this page, you can also find the previous events and the videos. And now to the thousands crate. So here in crates.io, we can see this crate, and it's very at the end it doesn't do much. Okay, what it does, what I also call I saw other people calling this commafying thing. So adding commas to a number. So you have a number like this, and you would like to make it more readable when you're printing it out, and then you want it to look like this. So there is a comma after the three digits from the right. And the same with negative numbers, and same with numbers which has a decimal point in it. So that's the basic problem. And this crate, it's called thousands because every thousand will put the comma. But I also saw the word commafy. So I actually implemented something like this, commafy. Do I have it? This is sort of the word. Let me see in the crates if it's there. So crate IO and commafy. I think I have. Yeah, I implemented something for the liquid template system, which I call liquid filter commafy to allow it in the filter. It's not that good, not as good as the thousands crate, and I might need to just switch over and start using it behind the scene. Anyway, so this is what the crate does. And in the README, you can see how to do this. So basically, you say use thousands and some stuff here. And then you can also set up some policy. You don't really need that actually. And then you can use all right, so this is the first example actually that what you can already use, that you can just say use thousands separable, and then you can use this method, the separate with commas method on numbers or variables that contain numbers. And then it will give you a string with the comma in there or commas. I already have the code cloned in locally, so I can start running it with, opa, it's opened in another window. Let me try to find that window and find the, sorry. Yeah, I have to, yes, okay. Let me enlarge the font. Also, please let me know if the fonts are good size or not, or whatever, if you just can't properly see what we have. I guess I already had it everything opened, so we can start from the beginning. And let me try to look at this one first. So if I look at the structure, first of all, I noticed there is a Travis YAML file, which is probably indicates that it's a rather old crate when Travis was still working for open source projects, and there's no .github folder, so there's no GitHub actions. So if any of you are looking for some contribution to contribute to an open source project, maybe that would be a good idea to create a GitHub action configuration file. Let me just see this. So this was the old CI system, an old CI system that was used by many open source projects. It says that to run it on various versions of Rust. It also says on 1.22, and if I look at it, Rust C minus Rust C. Okay, we are at 1.83. So 122, when it was added, apparently, that was rather a long time ago. And that's it basically. Just I guess Travis knew by default that if it's a Rust, if the language is Rust, then what it has to do is run a cargo test. So I can do the same thing, cargo test, and that should compile the code and run all the tests. Now, apparently, I already have, I mean, definitely, I already run this, so it was very fast, the whole compilation installation phase, and this is how the tests ran. Okay, if there is a library crate that has a .github folder, then I would look at probably I would look at the GitHub actions to see how to run the tests if they are something different than the standard. And what shall I do now? So I guess there's no main file because this is a library. So the first thing I would probably look at is the lib rs. Actually, maybe what I need to do is try to find where is this separate with commas comes from. Okay, so I'm going to look at this separate with commas. So I was thinking, how can I look at this if I should start reading the tests and see how to read that, or if I should write a small program that will use this crate and then start following the various links, the various method calls. So here I can see that this is in the README, I guess. So this is the example, more asserts. And here is the implementation of this. Okay, so that was the implementation. So when we call this separate with commas, actually what happens is going to call this separate by policy that we also saw in the README, and apparently it provides to it a default policy. So the separate with commas is the same as separate by policy with this policy, with the comma separator. So this policy, policies. So this is a const. Okay, wait a second. Yeah. So policies is a file, right? And then there is a constant called comma separator policy, which is a type of a separator policy that has apparently three fields. The separator itself which is a comma. It indicates that it's apparently this means that after every 3 characters, that's I guess, and dealing with ASCII decimal numbers. I think that's what, so it won't handle Unicode numbers. I don't know, that might be what it means. So this could be the default, and the separate policy is just something that you would probably have to implement in more of the. So this is just a definition of a trait, right? Because here we only have the definition of a function with the signature. So it gets the separate by policy gets a policy and returns the string that we were hoping for. And this is, if I scroll up, let me close. No, it doesn't close there. Okay, what's going on? Okay, I closed it. So yeah, this is what we have, the separable trait. So it seems that we have a trait called separable, which has several methods that we somewhere we'll have to implement those methods, because well, this one is sort of implemented. Okay, it calls, this is what we saw earlier, and then there are separate with spaces. So there are, okay, so it seems, okay, what I understand for now is that there is the separate by policy, which is the big thing that does the work. And then this trait has a number of other methods that are using specifically, that using policies that were defined upfront, I guess, because these are sort of the common or the expected common things. So putting an underscore between every three, or putting a dot between every three, or putting a space here, or putting a comma. Okay, I think I started to understand this now better than earlier. So let's try to figure out what is the separate by policy. So we see that it is defined a number of, and it's getting, just a second. Yeah. I'm a bit excited or showing this sort of live and whatnot, and showing how much I might not understand what I'm looking at. So there is this trait, right, that which is called separable, and which defines a method, and apparently it is implemented in various places. Okay, so for example, here we implement for strings, and here we implement it for any type. Okay, so this T is I guess it's for any type it implements. Actually, it's not any type. It's types that they already have a display trait. I think that's, yeah. If they already have the display trait, then those types will also have this separable trait, or sort of they can implement the separable trait. And in order to implement the separable trait, we need to implement this separate by policy function. Okay, good. So for every type, okay, every type except for strings, right? At the top, we saw it that we implemented the separate by policy method for strings. So he implemented it for strings. Here we are implemented for anything that's that has a display, I guess, except for strings. Now I don't really know how, because strings also have display. So I wonder if this is because we have a more specific one. That's why it will take for strings the first one, or because it comes before. That I'm not sure. But this for any other type, basically it just converts it to string, and then calls the separate by policy on the string. So it will just call this method. Okay, so for every other type. So basically we'll try to figure out how it works for the separate for every other type. So basically for strings, sorry. So basically this is the way, if you'd like to add any method or a method, if you'd like to add the method to any string that just people can create, then you need to implement some kind of a trait for the strings, and then people can call those functions. Now, because the separable trait was implemented here, we can call for strings, we can call any of these methods, and then they will call the main one, which is the separate by policy. So this separate by policy gets the policy. Where is this one? I never know how to close on the left-hand side except of clicking on the top one several times. So it calls this this long one. Okay, so this is the separate by policy. It calls this find span. It gives it the self, which is the string that we are going to work on it. And there is this what is this find span? Okay, find span. Okay, it gets a function. Okay, so it gets a closure, right? A function that gets a character and returns a Boolean. Okay, and len not matching. What is this len not matching? Okay. Okay, so I guess this is the whole thing is trying to find how the characters, how many characters are there, and after how many characters we'll have to put in the commas. Okay, we'll have to get back to that later. I didn't understand that. Okay, this is a string that I guess this is going to be the resulting string, and it's created with capacity. The length of the original plus the iter sep length. Okay, so let's say you have a number that has 6 digits in it or 5 digits in it, okay, just an integer number for now, and that will result in a string that has 6 characters, right? Because 3 digits, comma, and 2 more digits. So it's 6 characters. So it's already preparing a string with the exact capacity. Okay, so in Rust you can because it will dynamically allocate the memory, right? If you created an empty string that we are going to fill up, then at one point it might not have enough space to enlarge the string, so it will have to move it to some other place in the memory that Rust does behind the scenes. But if we would like to avoid that extra copy behind the scene, then we can pre-allocate, or if we want to use that word, enough space for the string. And that's what we do with this, that we say string with capacity. So it will create us a string that has enough space in the memory to grow up till this size, which is the length of the original string, okay? Because we already have the number as a string, remember, right? If we had a number, we converted it. Why don't we multiply by the number of commas added? No, that's the number of commas we are going to add. We don't have the string yet. Okay, we don't have someone asked why don't we multiply by the number of commas added, because we haven't added the commas yet. Okay, so here I guess the find span tries to find out how many commas we are going to add, and then this knows now, the iter sep len knows how many commas. So this is, I guess, the number of commas that we want to add. So we allocate memory, enough memory to put the new string that has the numbers, digits, and the dots, and whatever characters there were already in the original string, and the commas. And then we push on whatever was before okay. So that's a question, what is before here? Now we should figure out what is the before and the after and the number and the count that we got back from this fine span. But what I can guess is that before is will be returned by this fine span the characters from the original number that come before any comma that we will want to add. And then 4-digit, okay, so this is what my assumption now. And then 4-digit and comma after in the number characters. Ooh. Interesting. Okay, so this is going over the digits that we have in the original string after the ones that came before any comma, and then if there's a comma, then put the comma here, which is not necessarily a comma really. So here it should be called separator after, not comma after, if you're already talking about generic word separators. But I guess that's fine. So the default separator is the comma, and that's why it's called comma after. But in the policy, it's already called separator. So we push on the string the separator character, which can be comma or space or whatever you like. I guess you can put your own emoji there, which is actually interesting now that I'm thinking of. What if the separator is not a single byte? Are we allocating? Okay, so now I'm getting confused because of about bytes and characters, right? Because characters are not single bytes. So that's an interesting question now. Sorry. That's someone calling me, and I had to turn it off now. So, right. So that's an interesting question. What will happen if the separator is not a single character, not a single byte character, okay, but something which have multiple bytes? Okay. We can actually try to see the tests. Okay, let me try a test now. So where are the tests? Policies, Control F, test. Okay, so display, there are tests here. Okay, so apparently you can, apparently I'm not the first one to think about it, but the author also thought about it. What happens if you put an emoji or even multiple emojis as separators? And so there you can see that there is a test case for that, okay, with the smileys. So, okay, I can put aside my worries. Apparently this works. I just don't know exactly how. But this is how we push on one more character, which can be multiple bytes. And then at the end, so this is the loop where we push on all the characters and the commas. And then I guess this is what comes after all the commas. So if I'm not mistaken, and again, we can try to look at the tests, if there so what happens, that's the question now, what happens if you have more than 3 digits after the decimal point? Should there be commas there as well? Should those be separated as well? Or only the values that are after that before the decimal point? So I don't. So these are the tests. Minus sign. These are all the tests here. So let me try to add another test case here. for now at least. Maybe there is already, I just couldn't find. So many digits after the decimal, and that would be this. So I have a number that looks like this: 1, 2, 3, 4, dot, and then 6, 7, 8, 9. Okay, and I don't really know what should be, so I'll policy hex separate with commas. Okay, this is separate with commas. Okay, this is basically what I would like. So basically like this. Okay, separate with commas, and then I don't know what to expect. Okay, so let me run this cargo test, and obviously, I mean, right now I'm expecting this to fail because obviously that's not. Okay, someone is writing, it depends. Okay, so usually the separator is a single character, same as a byte. Usually, yes, but what I was trying to discuss is what happens if not. If someone wants to put an emoji, and then someone writes, it depends in UTF-8, which is the most common, then yes, I guess. Also in ASCII, which is the old standard and doesn't support other languages except English. Not even emojis, right? Sure. Yeah, so ASCII is basically the first 7 bits or only. So in UTF-8, that's only one byte, and that's really the most of the cases. But I always like to break things. So this is what we got back, right? This is what we got back. So I guess this is what we want. Okay, I don't know. This is what the program does now. Okay, let's run it this. Okay, yeah, so this is fine. So what I was wondering is whether it will going to put in a comma in the digits that come after the decimal point, and as you can see, it doesn't. So what I can guess now, right? So it put the comma here, but not here. Okay, so what I can guess now, if I go back somewhere in the code, where was I? Here. So the thing after is what comes after the area where we deal with commas. So I guess the decimal point and after that. Okay, so far so good. We'll still have to understand what are these separator, iterator, and find span. But let me try to. I try to avoid it because I didn't understand earlier. Let me try to do something that I think that I still understand. So the tests look not very complex. So we have this definition of tests, and then these test functions, which just do something and compare it to some expected result. And here we have, which is just the separate with commas, fine. And here we have a specific policy that says the separator are 2 smileys, the group is 1, and then the digits is not different. It's a sad face. Okay, what should this be? I have no idea. Okay, so now if we have 1, 2, 3, 5 sad faces and 2 spaces around it, then it will have, okay, between every 2 set faces. Oh, why did the author use yellow emojis and not red ones and different really drawings that would make it easier to see this? Anyway, 1 set face, 2 set faces, so 2 set faces, and between them there are 2 smileys. Okay. Oh, I think these digits are the acceptable characters. And they are called digits because originally the idea was that we are handling digits, right? And so what happens, let's say, if I put here, if in the original, okay, what happens if in the original text I also put here just the character X, okay, and run cargo test. Okay, so it just failed. I thought it's going to do some more damage. I thought that it won't accept this, that the character X that I had here wasn't in the digits list. Oh, okay. We'll try to see that in a bit. What are these digits here? Okay, so more examples for the tests. Okay. By the way, if you have any comment of what shall we look next, let me know. I'm just trying to play with this. Rates, we saw this. Okay. I wanted to start with the libs earlier. So in the libs file, what we see is just some comments, some documentation, and then the loading of the various modules. Okay, what is these digits? Okay, there are just two constants, the ASCII decimal digit and the ASCII hexadecimal digits. Okay, good. That's not very interesting. What are in the helpers? Lots of things. So we had this separator iterator that we wanted to understand what it does. What does it do? Exact size iterator test common. Okay. Digits are the characters to work on adding separators. I'm reading the comment. Other characters like spaces are just copied over to the result. So you need to add that X to the result as well to run the test. Right. So yeah, so okay. So the part that I understood that it failed because the expectation wasn't correct because I had the X. So that's fine. And what I didn't understand, and thanks for explaining, is that the field digits is the lists the characters to consider for separation. I think that's what you write basically, and the rest, what you wrote is to copy over the stuff. So, for example, if you have a number that already, I don't know what would be a normal case for this actually. I mean, if you just have regular numbers, then doing this, then you don't have anything except of the regular numbers where you put one in that thing. So, right. What I didn't mention, just a second, I have to drink. But I mean, I didn't mention explicitly, but you saw already that this crate can work on anything, not just on strings. On any other type, it can do the work if you just convert that thing at any type that has display, right? So it will just convert it to a string and then work on that string. So theoretically, there could be all kind of other characters, not just the ones that we would want to separate. Okay, I'm trying to figure out this one. No, 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 no. Traits we had. Display. Okay, we were here. Defined, and then the separator iterator. These are the two things that I don't understand, and maybe I won't, maybe I will never understand. Okay. So this find span, again, what does it do? It gets the self and it gets a closure that basically a function, right? That itself has receives a parameter which is a character and returns the policy digits contains. So it checks if the policy digits contain this character. Okay, so because we know now that the digits is a list of all the characters that we want to separate, this will just check whether this will just return true if this is one of the characters we would like to separate. So the find span now has this isDigit function that it's probably not really named properly now. That I guess it started out as a crate to separate digits, but now it can do anything. Okay, so it calls the len not matching with the string. Okay, so s this is self. Okay, earlier, but now it's called s. So right, if you go back, this s is the self in the is the current string. So len not matching, it's here. Okay, it gets the string and this function isDigit f. Yes, so this f is a type. Okay, someone is leaving. Okay, see you next time. So this f, okay, is a type that has to match this thing. So this means that it has to be a function that receives a single parameter, which is a character, and returns a function which is a Boolean. This is what we passed earlier, right? So we understand that already. The reason it was passed that way is because this is how the function is created. So this is just doing that. So this isDigit is a function like that, and then we pass on this function to the next thing. So the next thing also gets this function. Here it okay. So this is what slightly confused me, because it's the two different ways of writing the same thing. So here the author defined the f, this type f that needs to be this format. Okay, and I don't know what's the name of the definition when the definition comes immediately after the name of the function. But here we have a where clause, okay, which does exactly the same thing. So it says, okay, we have a type which we call f that has to match this. Shall I call it signature? I don't know. So this is the same thing, right? Okay. And this mode of writing is it's going to be better if we have a lot of things to put here. Okay, so maybe in this case it's a slight overkill, and as you could see, it also confused me for the first. But okay, and I should have put this at the beginning of this video, and that it's not a critique of the crate. Okay, I don't think that I would be able to write anything like this. Far from it. Okay, it's me trying to understand it and trying to figure out, and like in my consideration, okay, I personally write code like, okay, in the expectation that I'm going to improve it at one point, and then sometimes I manage to improve it, and sometimes I don't have time for it. So it's absolutely not a critique of the, or not a bad critique of the author. So we have this function. Okay, so it's exactly the same thing as earlier, and it returns a usize. So if this gets character indices, what is this thing? Okay, I have no idea what is this. This already comes from an internal library of Rust. At least so I understood, right? Yeah. Yeah, it's somewhere in deep in Rust core library. So maybe we are not going to read that. Someone writes, I believe it returns all the indices within an array where the character appears on. Okay. Actually, I can put this one and maybe it explains as well. I didn't think about that one. Okay. Returns an iterator over the car of the string slice and their positions. Okay. So it returns both the slice, I guess, and the position, as whoever wrote this, Diana, wrote it. Thank you. Okay. So it yields tuples. The position is first, the car is second. Okay, let's look at the usage, word car indices, and then assert equals 7 count. So it has several. So this would say, okay, it has seven iterations because goodbye apparently has 7 characters. Good. Okay, I've counted. Yes, and then it shows that on each iteration, what is the next value. So it goes over each one. Okay, good. Thank you. Okay, so what can we do this? So this goes over, and then it will find the character, find the thing, okay, where the second value, right, the character, is calling that function that we passed to the find span, and it will receive the current character, and then this predicate, okay, the pred stands for predicate, I guess. So if I go back to where the find send was called, you remember it checks whether the given character is within the policy, within the digits of the policy, right? So this one, so the predicate, and this p.1 is because this is a tuple, and so the zeros element is the usize, and the first element is the character. So this refers to the character and calls that function, the predicate function that we received here, which was originally passed on to us from the find span. And so if and then we get this tuple here where we only care about the location and not the character anymore. And so if there is a hit, if there is a match, then we return, I mean, this is the return value of the function. Okay, sorry, this is the return value of function. The bool confused me a little bit. This bool confused me here. So u size is the return value. So it's either we return the index where we found this character, or we return the len. And I guess find will match the first one, right? Or searches for an element of an iterator that satisfies a predicate. Find takes closure that returns true or false. It applies. Blah, blah, blah. Okay. It doesn't say anything what happens if there are more. Do I have a find all? Searches for an element of an iterator that satisfies a predicate. Okay. Oh, it is. Find is short-circuiting. In other words, it will stop processing as soon as the closure returns true. I somehow am missing here the word first. Search for an element of an iterator that's a predicate and returns the first one. I would probably write, if I understand correctly, what it really does. So this will return the first one. So this is the first one. Or if it couldn't find, then it will return the length of the whole thing. Someone is writing, it looks to me that the whole function returns the first index of the match, and if no match, returns the outside of an array occur length. Okay, yes, okay, we agree. Thank you. It just took me a little bit longer to understand this. Okay. So len not matching. Why is the name of the function is len not matching? So len if not matching, okay, something, okay, whatever. Okay, so this is the start, and it's a use. Okay, so this is the start, which is okay now. It's the first is the index of the first character that matches. So this is the index. Yeah, so that's the first character that matches that we need to deal with. Okay, so before that, there might be other characters that we don't need to deal with. Right, okay, so there might be digits, and before the digits, there might be other characters, and that we don't deal with. Okay, let's talk about digits now. It's easier. So this is the first digit that we have to deal with. Okay, len and count matching. Okay, so what is len and count matching? It gets a slice. Wow, it's already 50 minutes. Okay, it will take some time. A slice from the start. So it's just starting from the point where we know that this starts there, and the isDigit function, the same thing. So len and count matching. Okay, it's gonna be easier. It returns two usizes. Same signature here. It gets the same predicate. So far, so good. There is some counter here, I guess. It finds that it uses the previous function, the len not matching, to find the first character that matches again. Okay, so I guess what it said, what the assumption is that you might have digits in between. Okay, so sorry, there might be non digits between the digits. Okay, so assuming we are dealing with digits only, we have some garbage. Let's call it garbage. Then some digits, maybe some more garbage, more digits, more garbage, and then that's what we need to somehow deal with. Okay, I'm trying to think about something like this. So we have something like text 1, 2, 3, A, 4, B, 5, C, 6, and then it will only handle the digits. That's sort of what I understand. Let me try to check it with the test. Okay. So, all right, this is actually a good thing. Oh, we can write tests. Mixed. This is what I wanted, more or less. We can separate with commas. I'm going to leave this empty to see what's actually, what do I actually get there. Maybe I will even put here more. Okay, and this is we got back the same thing. Ah, okay, 4, 5, 6, 7, enough. Okay, I think I understand now. So, right. Okay, so it takes, so we have this, I don't even need this. I can put just x's here. Okay. Gonna be easier to understand. So we have garbage, and in between garbage, we have significant characters, okay? So digits in our case. And then it will take separately each section of these digits and apply the commafying thing on it. So if we, let's put here 6, 7, and here let's put 1, 2, 3, 4, and here 1, 2, 3. Okay, and then it will apply, let's see, so it applied the commification here, and it didn't do it here. Oh, I'm in ruins. Why? It does it only for the first one? Okay. I thought it was going to do for each one of them. Maybe this is a bug. I don't know. I put it here for now, and then I'll think what to do with it later on. But at least we know that this is the behavior of it. Okay. We were on line 53 sort of earlier. Let me close this one for something. Yeah, okay, and I can remove this one. I don't need this. Okay, maybe I'll create a pull request and send these test cases later on. I'll have to figure out and if one of you look at the source code and find similar test cases, so I won't embarrass myself sending a pull request for something that already exists. That would be nice. So this one, we were reading this one, len and count matching. And it will find the location. Okay, need to drop. Thanks for the event. Check remaining on YouTube. Okay, thank you for being here and thank you for your help. Yeah. Okay. It's already almost an hour. I think I'm going to finish it soon, even if it don't cover the whole crate. But I mean, we understood some. I'll try still to go on now. So this one, actually, one of the things that I would probably do is run the code. Maybe look for a unit test for this function. Is there maybe a unit test for this function? And to understand what it does. Well, it doesn't have a unit test. Okay, it's only mentioned in 2 places. But maybe I should write a unit test to understand. So just a test case that will run this function to see what it does. So this would, okay, so we have a string that we start going over. We find the first place where something is not in the digits, and then what is this? This continues. Okay, sorry. We get the string, and then the predicate is this. If the original predicate matches, then we increment with 1. So if it's a good character, a digit, we increment the count by 1 and return false. Otherwise, we return true. This is what the predicate does. Okay, trying to wrap around my head. So this will count how many digits we have in the current section and return the length of the current section. Shouldn't it do for... Yes. I think I understand now. Okay. So you remember that just a few minutes ago, I was trying to figure out if it's going to work on each one of the sections of the digits. And we found out that it only works on the first section of the digits. And this is exactly because of this. Because this function, and I'm not saying that it should work on the other parts. I'm just saying that I think I understood why it works on the first one. So this function will consider the first, we already know that it starts from a significant character, so from a digit, a character that we would like to handle, because we already removed or we didn't pass in all the ones that were before the garbage parts. Okay, and then it finds the first, again, it goes over and counts how many good characters we have, okay, digits, and on every time it returns the predicate, the internal predicate. So this is our predicate function, right? This whole thing is the new predicate function that gets the len. So it will return false, meaning that keep going every time we have a good digit, and true when it's a bad digit. So it will return how many times we have good digit in the first section. And so this is it. So it will return this section. It will only consider this section. This function doesn't consider that there might be other sections. Whoever went, okay, bye. How long is this file? 120. Okay. So we were here in 53. Sort of. Okay. Right. Okay. So this one again returns the length and what is the length and the count? Sorry, again. The count is how many good digits we have, and the len is the first place it is the total length of the string, I guess. No. Strange, I'm not sure. Okay, I'm not sure what is the length and this what was is the so this the len is what this len not matching returns, and the len not matching is returning either the first character that matches this. Okay, the first character. Well, it's complex, but I'm not sure if I like this. That it's very clever, okay, and I can imagine myself writing this 30 years ago, not anymore. So it's sort of the other way around now, right? It's trying to find, and maybe if I would understand the name of the function, it would be clearer for me. The first time we call this len not match, we are looking for the first character that is a good character. So we say, okay, find, we call this find, and the predicate is match the a character that is a digit. Okay, so it will find the first good character. Okay, let me call it that way. This time when we call it, we have a different predicate. In our predicate, it will return true if it's a bad character. Okay, because it now we have the predicate twice. That's why it's also confusing. This is the pred, the function, okay, the original function that we also used here, okay, the same function, which returns true if it's a digit. It's a good character. But we also have the predicate of this one that we are passing to the len not matching now, which is a different function, and this will return true this is basically returning true if the other predicate is false. Just in the meantime, goodbye to all those people who need to go. Fine, I planned for 1 hour. I'll keep going for a while now because I enjoy that. I think that I understand stuff. Okay. So this is now the opposite. Okay, so basically is the negation of the previous predicate, except that it also counts how many times it failed. Okay, how many times right, how many times it found a correct character or a good character. Okay. Wow. So what we have here, start is the number of characters that we disregard. Count is the number of characters that we have to handle now. And now I don't know what len is again. It should be the same or should be one more, I guess. I don't know. Okay, let's see. The limit is the start plus len. Okay. So this is what find span returned to us. The before, it returns the string before. Okay, it doesn't return. Okay, it doesn't return the numbers anymore. It returns slices. Slices. That's the right word here. Okay, of the original string. References to the slices of original string. So the part before the start to the limit. Okay, so all the characters that we actually have to deal with, which is between the start and the length, and then from the limit till the end. Okay, that's what we get here. Okay, so we get three strings and the count of how many digits we actually deal with, which is the length of this one, I guess. This should be the length of this one, I think. I'm not sure because I'm not 100% sure the difference between len and count. So this is what we got here. The before, the number. Oh, okay. This is the original number that we are trying to, so the number that we would like to separate. Again, this is not necessarily a number because we don't necessarily deal with digits, but this is the thing that we would like to actually separate, that have to separate, and then everything that comes after it, and the size of whatever we want to separate. And then we have the separator policy, which has the policy, okay, that we received from the caller, and how many times we have, how many characters we have to go over, how many characters from the number we have to go over, and that's the separator iterator. Fine. And then I'm going to get into that in a bit, how that looks like. It's a huge chunk of code, but I'll try to go over it. And then I go over the number, that string, cut it up into characters, and zip it with the iterator. What is zip? What does it really do? Zip up two iterators into a single iterator of pairs. Okay. So we have the iterator going over the characters and the iterator going over, I don't know what, this iterator, the separator iterator. We'll see that. Okay. And on each iteration, we get the character, the digit that we handle, and a Boolean, whether we should put a comma after it or not. Okay. And then we push on the digit, and then if we should put a comma after it, then we put a comma or separator after it. Oh, okay. So let's look at the separator iterator thing. This is the constructor, the new method. Okay, this is the policy, sum. Okay, I think I personally got really tired already. I might try to go over this part separately in a separate meeting or myself. I don't know. I think I'm personally I'm happy with what we got so far. I hope that you also enjoyed it and you learned something from it. Maybe that you don't want to do any code reading in public, but something. So thank you for being here. I'm going to close the video now. If you've watched the video so far, then thank you very much. Please like the video and follow the channel where you found this video on YouTube, and join us in one of our meetings later on. And those who participated here, especially those few who stayed so far, thank you very much. If you stay after I stop the recording, then we can continue a little bit the conversation or talk about how to find jobs in Rust or whatever you like. So thank you very much and bye-bye.